In our last lesson, we talked a little bit about what an arithmetic sequence is, and I just have written down a quick example of an arithmetic sequence. So our terms in the sequence are 3, 5, 7, 9, 11, and then dot, dot, dot. And the three dots, of course, mean that this goes on forever and ever. It's an infinite sequence. When our first differences are constant, so yesterday we had talked about setting this up kind of as a table of values where x represents the term number and the y is actually your term's value. So we actually then switched that to, instead of being x and a y, we switched that out to be an n for the term's position. So n is the position in the sequence, and t, I think I'm back to where I'm supposed to be. And then t with a subscript of n represents the term's value in position number n. So in position 1 in this sequence, the term has a value of 3. And in position 2, the term has a value of 5. Position 3, the third position, the value is a 7. And the fourth term in our sequence is 9. The fifth term is 11, and so on. So we talked about the n can only be whole numbers because we just have first, second, third, fourth, fifth, sixth term, and so on. We also talked about the fact that if we were to take differences here, we're going up by 2 every time. So we're adding 2. Let me see if I can move, whoops, undo, move this over a little bit. We're adding 2 here every time. Or if you're talking about the difference, we're really taking the term below, subtract the term above it. So 7 take away 5 gives you positive 2. Or 9 take away 7 gives you positive 2. 11 take away 9 gives you positive 2. That difference, that value we're going up by, is denoted by the letter D. So the first difference between adjacent terms or terms side by side, doing that difference in your y values, that is denoted or marked by D, the letter D. So D is equal to term n take away the term before it, and the term before it is n take away 1. So if we do 5 take away, so up here 5, that could be term 2, take away term 1, which is 3, that gives us our positive 2. Okay, but you can think of that as our first difference. We talked about this being linear and fitting our y equals mx plus b format here, y equals mx plus b. That first difference is our value of the slope, or the m value. Now what we did yesterday to come up with our b value is we just extended that table upwards and said for the y-intercept we would need x being 0, and if I follow the pattern backwards and subtract 2, this would end up being a positive 1 here. So I want to show you how this fits in with what we have just talked about. We have term n, so this is the nth term, so Tn represents the nth term of our sequence, so the general term, is equal to, now the letter A, when we're working with sequences, and it doesn't matter if it's arithmetic or geometric, the letter A is always the first term's value in that sequence. First term value in the sequence. Sorry, I've got my clicky stylus today. In the sequence. Okay, so in this case, our A, in this particular example, A is equal to 3. And we said our D is equal to 2, because that's our first difference. That's what we're going up to, or up by every single time. So here, our D value, if I can slide this in here, D, we said, is the common difference, or the first difference. I need an R in there. First difference, also known as the common difference. It's the thing you're having to, every time in common that they have in common, it's a value of positive 2. So I'm going to just put common, oh goodness, common difference in here as another name. But usually we'll call that first difference, just to keep it familiar with what you already know. All right, now the n we know, of course, is your term number. So n is the term number. So term number 1 had a value of 3, but n was 1. So this is term number, just like it was when we talked about it yesterday. And you might be thinking, okay, Logan, I'm not exactly sure how this is working here. Let's talk about this. And I didn't leave room for this, but I want to show you how this is actually true. We know that term 1 in the particular sequence that I've given as an example up here, I'm just going to slide back to my blue pen. I'm going to put this in and then I'll probably have to erase it because I won't have enough room. I'll just slide this in here. We know term 1 has a value of 3. Okay, so that's our A value. Our term 2, or sorry, our common difference was a 2. Now, we know we worked with y equals mx plus b. Okay, it's a linear relationship because we're adding a constant amount every time. Now, I want to look at what we have here. We have Tn being equal to the A value plus d times n minus 1. Now, if I were to expand this through, here's what's going to happen. I'm going to have my initial value of A, my first term's value, plus d times the term number, and then take away d, if I expand that out. Now, if I take my A value was the first term, if I put these two things together here, if I do A and I subtract D, what I'm really doing, I'm going to slide to yellow because I haven't used yellow. If I look at my chart here, I take my value of A, which is 3, and if I subtract my D, so subtract 2, do you see that I get that 1 value? That here, this and this combined together, that is my y-intercept. My D, that is my slope, and my n is like my x. So the A minus D itself ends up giving you the value of the y-intercept if you were to extend the linear relationship. Okay, so I just wanted to put that in there, why this little formula works. It's really doing what we were doing yesterday with these arithmetic sequences. It's just not showing the step of putting in the 0 in our chart up here, if you can see where I'm circling. Okay, so that's really what that is. This little formula will help us get there. All right, let's take a look at the example A. It's asking you to determine if the sequence is arithmetic, and if so, find the general term. So let's take a look and see what we can do with this. I'm starting at 2 and going up to 6, so it looks like I'm adding 4. And then from 6 to 10, it looks like I'm adding 4. And 10 to 14, I'm adding 4. 14 to 18, I'm adding 4. And I apologize, I squished those together so they might not look like plus 4s, but they're all supposed to be plus 4s. And because I'm adding the same amount every single time, it is arithmetic. Okay, so we know it is arithmetic. Now we need to find the general term. So a couple different ways we can do this. We can do what we were talking about yesterday in terms of, we know that the common difference is 4, so the slope is 4. So if we think of the y equals mx plus b, I'm going to do two solutions for this, y equals mx plus b. I know that the slope is 4, so I would have y equals, or Tn, I'm going to put it into my sequence notation instead. Term n would be given by our plus 4 is our slope, so we would have 4. Oh, goodness gracious, thanks almighty. There we go. We should have a 4 times the n, and then we need the y-intercept. So we could, I'm just going to switch colors here because this really wouldn't be a term in the sequence. I could subtract 4 from 2, and that takes me to -2, and that gives me then a y-intercept of -2 if I extend that. So that's a general term. Or you can use the little formula above. Tn equals A plus D times n minus 1. So our A value, I'm just going to circle that here in green, the A value is the 2, and your D is the plus 4. So we would have a 2, so term n is 2 plus, the common difference is the 4 times n minus 1. And then if I expand and simplify that, I'm going to multiply through the bracket here. I'm going to have a plus 4n minus 4. And the 2 minus the 4n goes together. They go together here. 2 minus 4n would be -2. So that simplifies then to 4n minus 2, which is exactly what we were doing up here with the 2 and then minusing the 4 to get the -2. We just did that step in our head. So whichever one works. We will need to eventually know this little formula because we're going to need it for other things to help us work backwards. Okay. The next one, if I take a look at what I'm going up or down by here, is it a constant amount every time? So I'm at -1 and then I go down to -4, so I'm really subtracting 3. If I go from -4 to -7, I'm subtracting 3. Going from -10 or -7 to -10, I'm subtracting 3. So again, it's arithmetic. I'm just going to put arith as a short form because I'm running out of, I might just be able to split. There we go. Arithmetic with the d value equaling -3. You could work backwards and add 3 to -1. That's going to take you to +2. So your general term would be Tn equaling -3n and then +2. So if n was 1, you should have -3 times 1, which is -3. -3 add 2 would be -1, which is the value of the first term. Okay, and you can check that to make sure it works. Or you could use that little formula we have, is your original a value, the starting term, and then d times n minus 1. A is -1, add -3 times n minus 1, expand and simplify, and we get -3n plus 2. Okay, so either one, whatever works for you. Try C and D and see if you think they're arithmetic or not, and then I'll go to a new video to take those ones up. Whoops, sorry.